Hi, welcome to my channel Electronics for Gate by Kota Venkanna. My mobile number 630-5826-909. In transmission lines, today I want to discuss the topic impedance matching devices. So already we have discussed about impedance matching. What is the main importance of impedance matching? So when more than two transmission lines are connected, in between these two, if the impedance is perfectly matching, then the maximum power or maximum signals are transferred from one transmission line to another transmission line. Otherwise, the signals does not transfer to the load and are reflected back to the source. So that's why we need to impedance matching. So here impedance matching devices for the impedance matching we are using impedance devices. So these impedance matching devices are basically two types. These are quarter wave transformer. First one is quarter wave transformer and second one is stub matching. So in this topics now today we have to discuss quarter wave transformer. Quarter wave transformer means so here in between this is the input and this is the output. In between input and output, the length lambda by 4 line or piece of transmission line. A piece of transmission line with the length L is equal to lambda by 4 is placed in between input and output. So here the maximum power transfer, our aim is to the maximum power transfer from input to output. So it is possible by placing the lambda by 4 line transmission line, a piece of transmission line in between input and output. Here it acts as a step up or step down impedance transformer. So that's why this is also known as impedance inverter. So quarter wave transformer is also known as impedance inverter. So here by choosing the proper characteristic impedance, so the output impedance either decreases or increases, input impedance either increases or decreases, and vice versa. So that's why this is also known as impedance inverter. So here we have to derive the equation, the relation between Zs, Z0 and Zr. So this is the load impedance Zr, this is the load input impedance Zs and characteristic impedance Z0. So we have to derive the relation between these three. So here this is the input impedance of low loss radio frequency transmission line, that is Zs is equal Z0 Zr cos beta L plus J Z0 sin beta L by Z0 cos beta L plus J Zr sin beta L. So here beta is the phase shift, L is the quarter wavelength, lambda by 2, that is lambda by 2, Z0 is the characteristic impedance. So here by connecting the load Zr, so by applying the length L is equal to lambda by 4 and by choosing the proper value of Z0, so then the input impedance may be derived or obtained. So that's why here L is equal to, in the quarter wavelength, L is equal to lambda by 4 and beta is equal to 2 pi by lambda. So here L into beta into L. So here beta into L is equal to 2 pi by lambda into lambda by 4. 2 pi by lambda into lambda by 4. Lambda lambda cancel. 2 2s are 4. So that is equal to pi by 2 beta L. In the above equation, in the place of beta L, we have to substitute pi by 2. So that's why Zs is equal to Z0 Zr cos pi by 2 plus J Z0 sin pi by 2 by Z0 cos pi by 2 plus J Zr sin pi by 2. So here cos pi by 2 is equal to 0 and sin pi by 2 is equal to 1. So by applying these values in this equation, then Zs is equal to Z0 Zr of 0. Why? Because cos pi by 2 0 plus J Z0 sin pi by 2 1 becomes 1 by Z0 cos pi by 2 0 plus J Zr sin pi by 2 1. So here 0 into Zr 0 plus here 1 into Z0. So then the value becomes Zs is equal to Z0 0 plus J Z0 by 0 plus J Zr. The value becomes Zs is equal to Z0 J Z0 by J Zr. So J both are cancelled. The above equation is Zs is equal to Z0 into Z0 by Zr. That is equal to Z0 square by Zr. So this is the above equation is written as Z0 square is equal to Zs into Zr. So this is the relation between characteristic impedance. This is the relation between characteristic impedance and input impedance and output impedance. So Z0 is equal to Z0 square is equal to Zs into Zr. Then so here Z0 square is equal to Zs into Zr. This is the relation between characteristic impedance and source impedance and load impedance. So here from this equation, Zs is equal to Z0 square by Zr. So here Zs directly proportional to 1 by Zr. So here if the Zs is increases, then Zr is decreases. If the Zr is increases, Zs is decreases. Here the quarter wave transformer line. So Zr, by choosing the value of Zs, appropriate value of Zs, Zr is smaller than Zs. Zr here Zr becomes smaller than Zs or Z0, smaller than Z0, and Zs becomes very much larger than Z0. So and vice versa. So that's why This quarter wave transformer is known as impedance inverter. Impedance inverter. So here Z0 is equal to square root of Zs into Zr from this equation. So here, by choosing the appropriate value of Z0, a lambda by 4 transformer line acts as step up or step down impedance transformer, and that's why this is called as impedance inverter. So by using the impedance inverter, the maximum power is transferred to the load from source. So this is the one of the impedance matching device, that is quarter wave transformer. So here in the next class we will discuss stub matching devices. So for daily classes and for any updates, subscribe my channel Electronics for Gate by Kota Venkanna. Thank you.